today in this video I'll be working on a very interesting project, that is I'll be creating a model that can predict either a person is a diabetic patient or not. So we'll be training our model using machine learning, and then we'll create like this user interface, a dashboard using Streamlit. You can see it is a very beautiful dashboard. We have here dashboard option, we have a sidebar, there is a predict option, and there is an about section about this project. This everything is created using Streamlit. So let me just show you the running of this dashboard. If you go to predict section, I have some values I'll be giving. These are the values from my data set. So yeah, I'll be entering those values. Insulin as 0, BMI in 6, yeah, and then diabetes pedigree function is 0.63 and age is 50. So if I click on predict, there is a scrolling, and then you can see here it is written diabetic, then probability of diabetes is 69.98%, and then there is a risk cause meter that is showing that the probability is little dangerous. So yeah, this is a beautiful dashboard. And here when we return to dashboard page after the prediction, you can see the statistical data. You can move this around. Okay, so this is a beautifully made machine learning model that can predict either a person is a diabetic patient or not. So let's get started into building this model. So I have created a folder named as diabetes prediction using ML, that is machine learning. So yeah, inside that folder I have created a virtual environment, and inside that folder I have kept my dataset named as diabetes.csv. okay, so now let me create a file, that is I'll name this file as dps_ml, and I'll be giving the extension as ipynb. So now let's start building this model. You can use either Jupyter Notebook, but I'm using VS Code here. So let me first import all the required dependencies. So first of all, I'll import numpy as np, then I'll import pandas as pd. Then from sklearn dot preprocessing, let me import standard scalar. Okay, again from sklearn dot model selection, let me import the train test split. Then from sklearn, let me import our model, that is svm. So in this model I'll be using the support vector machine for the training. And then last thing required is from sklearn dot metrics, let me import the accuracy score. So let me run this. Yeah, so now let me import my data here. So I'll name the variable as data, and I'll use the pandas library. So pd.read csv, then I've named my data set as diabetes.csv. yeah, and run this. Yeah, so our data is important. So let me check my data.head. So this is my data set. It has, yeah, this is my data set that I'll be using. So now before the pre-processing part, let me just analyze my data a little bit. So let me have the shape of my data. So yeah, my data set has 768 rows and 9 columns. So you can see the columns here. And the last column, that is the 9th column, is the outcome column. That means it has two values, 0 and 1. 0 represents non-diabetic and 1 represents diabetic. Okay, so yeah, that's perfect. Now let me check the value inside this column, that is outcome. Okay, so let me have the column outcome, and I'll have the value counts. So you can see here there are 50 patients who are non-diabetic and 268 patients who are diabetic. So there's some good info about our data. Now let me check some more infos. Data.info. yeah, so there are no any null values in my data set. That's a good thing. There are 7 columns that are integer and 2 columns that are floating columns. So yes, that's perfect. Now let me get some statistical data about my data set. So yes, you can see the mean value of each column. So you can see the minimum value, you can see the maximum value, standard deviation. So yes, these are some statistical info about the data. Last thing I need to do before the pre-processing part is, let me just group my entire data set on the basis of outcome column and check the mean. Okay, yeah, So now you can see the entire data set is grouped on the basis of the outcome column. Now if you see here, the people who are diabetic patient have higher mean values than as compared to the people who are non-diabetic. Okay, so this is a good info our data set. Now we can move to the pre-processing part. Now let me split my entire data set into X and Y. So in X I will be storing every column except the outcome column. Okay, so I will be taking the data data, and then I will be dropping the column that is outcome. Okay, and I'll keep the axis as 1. All right, and in Y I'll be storing only the outcome column. So let me take the outcome column from the data. That's it. We have split our data into X and Y. Now what we need to do is, we can see in our data set that and the values are very much spread. Some are in hundreds and 200s, and some are between 0 to 50, and some are in 0, 1, 2, and that, so data is very spread. So our model can give imbalance, our model can be biased. So our data is imbalanced. So let us standardize our data. So we have import standard scalar at the top. So let me make a variable name scalar. I'll call out the function standard scalar. Okay, now what I will do is I will fit my X in this scalar. Okay, it's done. Okay, now let me create a variable standardized, named as standardized data, and then what I will doing is I will just transform my X, transform then X. Okay, it is transformed. Now the last thing left is I will be storing the standardized data again in the X. So that's it. Now if we check our X, then you can see the entire values are now nearby of the 0 line circle. Okay, between 1 and -1. So now our data is balanced, all the values are almost similar. Now what we do is we'll split our data set into training data and testing data. So I'll create 4 variables: X train, X test, Y train, and Y test. Okay, now I'll call out the function that is train test split. I'll pass out the input as X, Y. I'll give the test size of 0.2. I'll stratify this model on Y axis, Y column, and then last thing is random state. So I'll be passing the random state as 2. Okay, now our data is split into training data and testing data. So now let me check the shape of all this. I'll also check the shape of X train, training data, and then X test. Okay, dot shape. All right, if we see here, our original data that is X has 768 rows, but our training data has 614 and testing data has 154. So that means our data is split into 80/20 ratio between training and testing. Okay, now we can begin our model training. So let me create a variable model. Then in that model I'll be calling out the SVM, that is support vector machine, and then I'll be calling SVC. I'll set the kernel as linear, and then I'll give the probability as true. Okay, yeah, our model is called. Now what I do is model, I'll just fit my X train and Y train to the model, Y train. Yeah, so yes, our model is fitted. Now let me do prediction of my model. So first of all, I will be doing the training prediction. So I'll create a variable as training pred, and what I'll do is I'll call out model.predict, and I'll pass it X train. Okay, now let me also check the accuracy of my model. Let me just run this. Yeah, so now let me check the accuracy. So I'll be creating a variable name as training accuracy, and then I'll be calling the function accuracy score. What I'll pass here is the training prediction and original labels, that is Y train. Okay, now if we check this training accuracy, we print this training accuracy. So yeah, our training accuracy is 78.66%. So it is not that good accuracy, but for the data set, for such a small data set like we are using, it is a good accuracy. Okay, similarly we'll do the prediction for testing data. I'll create a variable testing pred is equal to model dot predict and then x test. Yeah, then I'll be going to testing accuracy, and then calling out the function accuracy score, that is testing pred to y test. All right, and now let me print the testing accuracy. So yeah, our testing accuracy is also similar to that of training accuracy, that is 77.27%. Okay, so yeah, that's good. So our model is working fine. Now let's make a predictive system. Okay, so I'll take a input data, I'll open my data set, and then let me take a value. That is, first of all, let me work with this one. So remember, yeah, first of all let me input this data. I'll just create, yeah, it's my input data. Okay, now what I need to do is I need to convert, I'll be converting this input data as numpy array. So let me create a variable as np array, and then I'll be doing it, will be converting it as np.asArray, and I will give it input data. Okay, after that what I will do is I'll reshape my data. Reshaped data is equal to input data as array dot reshape. Okay, I'll be passing it 1 comma -1. All right, that's it. Now I can do the prediction. So I'll create a variable as prediction, then I'll call out the model dot predict, then I'll pass it reshape data. Okay, no, before this we have one step left, that is we'll standardize this value into that 0 and 1 line access. Okay, so let me create another value, that is std data, then I'll be calling out the function that is scalar dot transform, and I'll be transforming this reshaped data. Okay, now we can do the prediction, that is prediction. I've created a variable named as prediction, and then I'll be calling out the model dot predict, and inside this predict I'll be passing this standard data. Okay, now this is our prediction. Now let's give it a condition. If our prediction equal to 1, then print yeah, let's just let me write it simply diabetic. Okay, else you can just print non-diabetic. All right, I see, that's it. So let me run this. So before running, let me check. This is the input data I have selected, and you can see its level, it is 0, that means it is a non-diabetic. Okay, run this, and you can see here it is written non-diabetic. Perfect. Now let me take a diabetic data. Let me check this one. Let me copy this and let me paste it here in the input data. Yeah, that's it. Now let me run it again. It is a diabetic. You can check here, it is a diabetic data. So yeah, our model is working perfectly fine. Now last thing we need to do is we'll be exporting our data. Yeah, we'll be exporting our data, and then we'll be designing the dashboard. Okay, so for exporting, let me just import a pickle. We need pickle for exporting, so let me just import pickle first. Yeah, I'll be calling out the pickle dot dump, and then inside that I'll be passing out the model and open, and I'll name my file as model.pkl, and I'll give this a write byte. Okay, I'll be giving it a write byte. Yeah, Also we need to export another one thing, that is we'll be exporting the scalar, because user will not be giving the data in standardized form. They will give the data as raw, that may be high or low. So yeah, we need to standardize that data. So I'll also be exporting the scalar model. So pickle.dump, name is at scalar, and yeah, open, name is as scalar.pkl, and I'll give it a write byte. Okay, now if we run this, we can see here two files are created, that is model.pkl and scalar.pkl. Now we'll be designing that beautiful dashboard using Streamlit. Okay, now let's start building the user interface, that is the dashboard that we have seen earlier. So now what I will do is I'll create a file named as app.py. Okay, so now here I will be importing this Streamlit as st, and then I will import pickle again. I will import numpy as np, I'll import pandas as pd, then I will import what is the plotly dot graph objects as go. Okay, so this we will be needing this for making that graphs. Okay, and last thing we need to import is import time. We'll be importing time. So now loading model. Okay, so let's create a variable named as model, and we'll call out the function pickle.load, and then we'll use open, and inside that we'll give the name of the file, that is model.pkl, and here will be using the read bytes. Okay, we'll also be importing the scalar one, so I'll name it as scalar, again pickle.load, then inside this I'll be giving it open, then we'll give the name to scalar.pkl. This will be also in read bytes. All right, so that's it, we have loaded our model. Now what we need to do is we'll call out the Streamlit function, and we'll set the page. Okay, we'll set page underscore config. We'll give the page title as diabetes dashboard, diabetes dashboard, and then we'll give the layout as wide. Okay, so we'll give the layout as wide. All right, this is done. Now we'll be storing the last user input. Okay, so we'll give a condition if last input is not in st.session state. Okay, then we'll call out st.session state dot last input as none. Okay, let's build a sidebar. So for that sidebar I'll be setting the title as let me give it as diabetes ml app. Okay, this is the title. Now again let me go to the sidebar, and I'll keep some info about the sidebar, and let me write here machine learning based diabetes prediction system. Okay, there's a little info about our dashboard, and then I'll be creating a variable name is page. Okay, and in that I'll be creating radio for our sidebar. So I'll give st.sidebar.radio name it, we'll keep info as navigate. And I'll be creating a list where I'll be passing out the radio names. That is, first is dashboard, second will be predict, and the last one will be about. Okay, now let's create the dashboard. Okay, dashboard, nice. So now if page equals to dashboard, if the page is equals to dashboard, we'll first set the title of the page as diabetes prediction dashboard. Okay, now let me create three columns, column 1, column 2, and column 3. And I'll call out the Streamlit function, and I'll call out the columns. I'll pass 3. Okay, now what do we do is, now column 1 we'll call out the metric, and we'll give it as model type. Okay, and then we'll enter here as SVM. These are some infos about our model to make the dashboard look more beautiful. So again, now column 2 metric, we have the features used, and then there are 8 features used, so yeah, we'll write it as 8. And the last column, that is column 3 dot metric, then we'll call it status, we will give it as active. Okay, that's it for the dashboard top part. Now we'll have a markdown here, so st dot markdown, and here we'll have a simple markdown. Okay, now I'll give a subheader, so we'll go to st dot subheader, and we'll write it as normal versus your medical data comparison. Okay, so this is a subheading. Now we'll score the normal values in a list. So these are some of the medical approved normal values of the features that are present in our data set. So yeah, 20, and then 80, there comes 22, 0.5, and then 30. These are some of the normal values, approx normal values. Okay, so now let's create a variable name as features equals to, let's create a list here, and then here we'll give out as, first is pregnancy, will create all the features that are present in our data set. Second will be glucose, third will be blood pressure, sorry, it's a little bit of error, blood pressure. After that we'll be having the skin thickness, and then we'll be having the insulin, and then we'll be having BMI values, and the last two columns are diabetes pedigree function, and the last one is age. Okay, age, yeah. So after that, now let's give a condition. If st.session_state dot last input, okay, last input is not none. If the user input is not none, last input is not none, then let's create a figure in the dashboard part. So we'll create fig equals go dot figure. Okay, now let's add fig dot add trace, we'll have a add trace, and we'll go call out the function that is plotly we had just had above graph. So go dot we'll create a bar graph, yeah, bar, and then inside that we'll pass out the values. Like for x we'll have features, okay, then y will have normal values, then we'll give the name as normal person, yeah. So first is created. Now again let's create fig dot add trace, and then again we'll go call out the go, and again we'll create a bar, and then here what we do is we'll give the x as features, okay. Now in y we'll call out the Streamlit function, and then we'll call out the session state, and we'll give it the last input, okay, and then we'll give the name as your input, okay. So now let's make an update layout. So I will write here as pig dot update layout. I will be calling out this update layout, and there I'll pass the bar mode equals graph. I'll pass the bar mode as graph. I'll give the x-axis title. Give the x-axis title as medical features, okay. Then I'll give the y-axis title as values. Give the y-axis title as values. Then I will give the main title as medical features comparison, okay. And I'll select the template as plotly white, okay. I'll select the template as plotly white, and then last thing I'll set the height equals to 500, okay. Now we have I'll call out the function xt.plotlychart. I'll pass figure, I'll pass the fig, and I'll call out the use container width, and I'll pass it as true, okay. Now let's create an else statement. Let me give some info. So I'll call st.info, and I'll write here as like please make a prediction first, to see comparison chart, okay. Yeah, that's it. Now let's design the prediction page. Prediction, yeah. So now let me call an elif, and I'll give pages equal to predict. If pages equal to predict, then we'll set the page title as predict diabetes, okay. Now I'll pass two columns, that is column 1 and column 2, and I'll call out the function st.columns, and I'll pass the value as 2. Now when in column 1, I'll create 4 variables. Pregnancies, first is pregnancies, and I'll call out the number input function. There I'll write as pregnancies. I'll give the range from 0 to 20, okay. Second, I'll create a glucose variable, and I'll again call out the number input function. Number input, I'll pass it glucose, yeah. So let me copy this, and I'll be pasting it 4 times, yeah. Third will be blood pressure, okay, and I'll pass it here as blood pressure. Fourth is skin thickness, I'll pass here as skin thickness, okay. Now when in column 2, with column 2, I will again create 4 variables. So let me copy paste it here. 2 3 4. Yeah, first will be insulin, and I'll pass it here as insulin. Second will be BMI. Third will be diabetes pedigree function. And the last one will be age. Okay, let me pass here as age. Now let's create an if condition. So if st dot button, so we'll create a button here, we'll name it as predict now. Okay, so now if this button is pressed, now we'll load a spinner. Okay, let me just load a spinner with, I'll call the Streamlit function, and I'll load the spinner. I'll write here as analyzing medical data. Okay, so now I'll give the time as sleep for 1.5. Okay, now we'll create an input data and we'll convert it into numpy dot array, and inside this we'll pass 2 lists, and inside that we'll pass the features, that is pregnancies, and then glucose, then comes blood pressure, then skin thickness, then we have insulin, then again we have BMI, then we have diabetes pedigree function, and the last one we have is an age. Okay, so these are all inside the input functions. After that, let me create a gap here. So yeah, so after this we'll call st dot session state dot last input. Okay, call out st dot session state dot last input, and we'll give it as input data, and we'll pass the list as 0. Okay, that means no value inside, that brackets will not be counted, so we'll only take the value inside that list. Okay, now we'll scale this data and we'll name this variable as input scaled. Now we'll call out the model, that is scaler, and we'll transform the input data. Yeah, now we'll make the prediction. Okay, prediction will be equal to, we'll call out the model and we'll predict. What will predict? The input, that is scaled. Okay, this was simple. Now we'll create a probability. We'll create the probability of the disease. Now what we'll do is model dot predict proba. Okay, and we'll pass here as input scaled, pass the 0, and then we'll pass 1. Okay, now we'll have a markdown here, st dot markdown. Again we'll create another if condition. Now if prediction is equals to 1, then what will be the display? So we'll give an error, and there it will be written diabetic. Okay, and else if the prediction is 0, we'll have a success, and then will display there non not diabetic. Okay, this was simple. Now let's pass an info here, st.info, and inside this we'll have we'll use forwarded strings. Inside that forwarded strings we'll write probability of diabetes. Probability of diabetes will be, we'll use curly braces, then we'll use round, and inside that we'll use probability multiplied by 100, we'll pass 2. Okay, we'll close this curly braces and we'll give a percentage. All right, now let's design a risk gauge meter. So gauge meter, yeah, we'll design a risk gauge meter. Now we'll name it a variable, that is gauge 2. We'll create a figure, gauge dot figure, and we'll geo dot, we'll call out the function indicator, and inside that indicator we'll give the mode equals gauge plus number. Okay, we'll give the mode as gauge plus number. We'll give the values will be probability multiplied by 100. Then the title will be, use curly braces, and we will use text, and then inside that we'll use diabetes risk percent. Okay, now I'll use gauge will be equal to, again I'll keep a curly braces, inside that I'll pass the axis will be equal to, and inside that we'll give a range. Inside this range we'll give the range from 0 to 100, 0 to 100. Yeah, after axis we'll give steps with the steps again in a dictionary, again in a list. Okay, and inside that we'll pass a dictionary where we'll have range will from, if the range is from 0 to 40, we'll have the color will be green. Okay, we'll copy this, a comma here. Yeah, so we'll copy this. After this we'll paste it 3 times. If range, now we'll change the range is from 40 to 70, we'll have the color to yellow, and if the range is from 70 to 100, we'll change the color to red. Okay, so now we'll in this gauge, and again then last is we'll update the gauge. So we'll create gauge dot update layout. Inside that we'll give the height, as 400. Okay, we'll call out this plotly chart. We'll pass gauge here, and then we'll use the container width as true. One we'll be creating is an about page about the project. So let's give an last else statement. So there is nothing much in this page, so we'll set a title that is about project. Yeah, about project. Yes, and the last thing we'll be doing is we'll write something about project. So we'll st.write, we'll create, we'll keep this in double quotation, and inside this we'll write info about project. So this project predicts whether a person is diabetic or not using a machine learning model trained on medical data. Okay, let's give a space. Here we'll write model used will be a support vector machine SVM, and the data set used will be an Pima Indians diabetes data set. Okay, that's it. This is our model. We have completed the coding part, so now let's check if our app is running properly or not. So let me go and open a new terminal. So here I will write Streamlit run app.py. okay, so if I run, so yes, our model is working properly, our dashboard is working properly. So we have this prediction dashboard. This side we have a sidebar which can be closed or opened, and there are three radio buttons: dashboard, predict, and about. If you click on predict, we go to the predict page. Here you can do the prediction. We have a predict now button. If you go to the about page, we have information about the project. We can write anything here. So let's go to predict. I have some data from my data set, so let me enter those. So yes, 0 and 3.6, 0.63, and age is 50. So if I click on predict now, there is a running spinner that says analyzing medical data, and you can see the result here as it says diabetes. So this data was for a diabetes model. So yeah, it is showing properly, and we have the probability of diabetes, that is 69.59%, and this is the risk gauge meter. Okay, so now if you go to dashboard, okay, so here we have some error in the chart place. So now okay, yeah, so let me go to the coding part. Let me check the error here. You can see here, okay, I have done error in this place of chart, so it must be y-axis. Okay, y-axis, yes, this must be y-axis, and another is, yeah, here instead of graph it must be group. Okay, so now if I save here and if I come here and refresh this, okay, let me again predict it. Same values, 6 to 35, 0, 33.6, 0.63, and age is 15. So if I click on predict now, this is working fine. Now if I go to dashboard, yeah, so here you can see the bar graph. This is a graph comparison between the normal values of a normal person and then your values. This red one indicates your values and the blue one indicates the values of a normal person. So if I use another data set, so let me go to diabetes. Let me get this one, this data for, this is for a patient who is non-diabetic. So yes, let me input this once. 189, 63, 66, 66, then we have 23. We have insulin as 94, 28.1, 94, 28.1, 0.167, 0.167, and the age is 21. Okay, if I predict, yeah, you can see this data set is of non-diabetic patient. So here it shows non-diabetic, probability of diabetes is 4.72, and this is the gauge meter. If I go to dashboard, this is the bar chart comparison between your data and the normal person's value. Okay, so yeah, this is it for this video. Thank you for watching. Stay tuned, we'll have more interesting projects in the upcoming videos. Thank you.